So in the fifth question, we are going to use Fertile2 database. Okay, so the database was collected on women living in the Republic of Botswana in 1988. The variable children refers to the number of living children, and the variable electric is a binary indicator equal to 1 if the woman's home has electricity and 0 if not. So let's start with the question. First, load the dataset Fertile2 equals to woo.data in the bracket Fertile2, and then use the head command to see the first few rows of this dataset. Okay, so these are the column names. Now, in the first part, it asks find the smallest and largest values of children and compute the average. So simply type the dataset name, select the children column, and then type minimum function. For maximum, use max function, and for average, use the mean function. So let's look at the answers. Smallest number of children in a home is 0. Okay, so there are some households where there are no children. Largest number of children 13. Average number of children 2.27. Then in the second part, it says calculate the percentage of women with electricity. So type the dataset name Fertile2, and in the square bracket type the column name electric, and then use the mean function, and then multiply this by 100. So it will give you the percentage of women with electricity. So the answer is 14.02%. Then in the third part, it says average number of children per women without and with electricity. So first we have to filter the data set on the basis of this electric column. Okay, so first we are going to calculate average number of children for women with no electricity. So type the dataset name, and then again type the dataset name, and then type this column electric equals to 0, that is no electricity. So this command filters the dataset on the basis of this value, and then it will return the number of children, the values in the children column for only these values. Okay, type the children name, children column, and then take the average of this values. So it will give you the average number of children for women with no electricity. For with electricity, perform the same procedure and just type here equals to 1, so that this command filters the data set according to this electric column on the basis of the value 1. So it will give you the values in the data set where electric is 1, and then type in the square bracket children column, and then type mean. So average number of children without electricity is 2.33, and average number of children with electricity is 1.90. So this dataset indicates that women without electricity in general have more number of children. So in the fourth part, there is interpretation of causality. Okay, so it says that women with electricity tend to have fewer children. However, remember this, correlation does not imply causation. There might be other factors also, such as education and income, okay, influencing both electricity access and fertility. Okay, now let's move on to the next question. In the sixth question, the dataset county murders is being used. And in this dataset, we have to use only the year 1996. And the variable murders is the number of murders reported in the county. The variable X6 is the number of executions that took place of people sentenced to death in the given county. And most states in the United States have the death penalty, but several do not. Okay, so first load the dataset country murders equals to woo.data, and in the bracket type county murders, and then we have to filter this dataset for the year 1996. So create a new data frame, counting murders underscore 1996 equals to, select the original dataset, and then we have to filter this dataset according to the value 1996 in the year column. So type dataset name again, and then in the square bracket year equals to 1996. So we now have the dataset for the year 1996 by the name of counting murders underscore 1996. Now type the command head command to display the first few rows. So these are the first few rows of this dataset, and here are the column names. Now look at the first part of the question. It says count the number of counties and those with 0 murders. So first we have to count the number of counties in total. So type num underscore counties, select this dataset name dot shape, and in the square bracket type 0. So it will give you the number of rows. And then we have to calculate those with 0 murders. So for this, create a new variable num underscore 0 murders, and then type the dataset name, and then again dataset name with the murders column equals to 0, and count the number of this dataset where murders is equal to 0. And in total we have to calculate the percentage. Take this variable in the numerator and divide by this variable in the denominator, and then multiply it by 100. So it will give you the difference in percentage. It will give you the proportion in percentage. So the total number of counties in 1996 is 2197. Counties with 0 murders is 1051. Okay, and so percentage of counties with 0 executions is 98.59%. Now we have to calculate largest number of murders executions and compute average executions. So type the variable name, create a variable by the name of max underscore murders, select the dataset name, and then select this column murders, and then type max function. For average and maximum executions, take the column x6, and for maximum type maximum, and for average type mean. So the answer is largest number of murders in a county is 1403, and largest number of executions in a county is 3, and average number of executions is 0.01. Okay, so why is this average so small? Because the average number of executions is very small, because only a few counties have executions at all. Now in the third part of the question, it says compute correlation coefficient between murders and executions. So create the variable correlation equals to, select these two columns, type the dataset name, and then type square bracket twice. Use select the columns murders and execs, and then type function CORR, and then dot ILOC in the square bracket 0, 1. This will give us the specific correlation between these two variables. If we do not type this command ILOC square bracket 0, 1, it will give us the whole correlation matrix. We do not want the whole correlation matrix. We just want the correlation between these two variables. So that's why we type ILOC square bracket 0, 1. It means give us the value which is present in the first row, second column. So the correlation between murders and executions is 0.20. Okay, so it is positive, but it is very low. Now interpretation of correlation. If correlation is greater than 0, yes, it is greater than 0. However, this does not mean that mean executions cause more murders. Okay, the correlation may be due to the fact that counties with more murders are more likely to have executions. So this is the logic behind this positive correlation. Now let's move on to the next question, the seventh question. In the seventh question, alcohol dataset is being used, and it contains information on a sample of men in the United States. Two key variables are self-reported employment status and alcohol abuse, along with many other variables. And the variables employ and abuse are both binary or indicator variables. Okay, so there are 4 parts of this question. Now let's begin by loading the dataset. First, load the dataset by typing alcohol equals to woo.data in the bracket alcohol, and then type the command print alcohol.head to look at the rows and columns. So these are the column names of the dataset. The first part is compute the percentage of men who abuse alcohol and the employment rate. It means that we have to calculate the percentage of values in these both of these columns where the value is 1. Since both of these are binary variables, so therefore we will calculate the average of both of these columns. Type %_abuse, round bracket, type the dataset name, and then type the column name abuse dot mean multiplied by 100. And for employment rate, employment_rate, dataset name, and then the column name employee, and then type mean function and then multiply it by 100. So let's look at the answers. Percentage of men who report abusing alcohol is 9.92%, and employment rate in the sample is 89.82%. Now we will calculate the employment rate for men who abuse alcohol. So create the variable employee_rate.abusers. Type the dataset name to filter the dataset on the basis of value 1 in the abuse column. Okay, so type this column name abuse equals to 1, and then multiply it by employee column, then type dot mean function and then multiply by 100. So employment rate among alcohol abusers is 87.27%. Now we have to calculate employment rate for men who do not abuse alcohol. So similarly, as we did in the previous question, we have to filter this data set on the basis of value 0 in the abuse column. Okay, use this command to filter the data set on the basis of value 0 in the abuse column, and then multiply it by the column employee, and then take an average of these values by typing dot mean function and then multiply by it 100. So employment rate among non-abusers is 90.10%. Now what is the interpretation of results? First, we will take a difference between the employment rate of non-abusers and abusers, and this difference is, look at the right hand side of the screen, is 2.83%. So the employment rate is lower for alcohol abusers compared to non-abusers. However, this does not imply causation. Other factors such as mental health, education, or economic background may contribute to both alcohol abuse and unemployment rate. To establish causality, we would need an experimental or instrumental variable approach. Now let's look at the next question. So we are here at the last question. So in this question, we are using EconMath database, and this was obtained on students from a large university course in Introductory Microeconomics. So for this problem, we are interested in two variables: score, which is the final course score, and econ HS, which is a binary variable indicating whether a student took an economics course in high school or not. So there are 4 parts of this question. So let's begin solving this. First, load the dataset by typing econmath equals to who.data in the bracket econmath, and to display first few rows, type the command econmath.head and then econmath.info. So this is the result of this command. Here are the column names. Okay, and the result of econmath.info is this. There are total 856 entries and there are total 17 columns. Now what is the first question? How many students are in the sample? So simply type dataset name dot shape and in the square bracket 0, it will give you the number of rows. So total number of students is 856. Okay, now how many students took an economics course in high school? For this, you have to simply type dataset name and in the bracket and the square bracket type the column name econhs, since it is a binary variable. So we will sum the values of this binary variable column. It will give us the answer. So total number of students is 856 and number of students who took high school economics is 317. Now we have to calculate the average final score for both groups. So first we will filter the data set on the basis of value 1 in the econ HS column. So first we filter the data set on the basis of value 1 in the econ HS column and then multiply it by this score column and then take the mean of this value. Then we will calculate the value filter the data set econ math on the basis of value 0 in the econ HS column, and then multiply it by score column, and then take the average of these values. So let's look at the answers. Average score for students who took high school economics is 72.08, and average score for students who did not take high school economics is 72.91. So the difference in average scores is minus 0.83. So what is the interpretation? In the third question, it is asking for interpretation. Does this indicate a causal effect? See, let's look at this interpretation. A higher average score for students who took high school economics may suggest a positive relationship, but it does not imply causation. There may be other factors influencing the scores, such as prior academic ability, motivation, socioeconomic background, or instructor quality. So in the fourth part, it is saying design an experiment for causal inference. So to obtain a causal estimate of the effect of taking a high school economics course, we need an experiment. A random controlled trial would be ideal. Randomly assign students into two groups, one required to take high school economics and the other not. Then compare the final scores in the university microeconomics course to determine if the high school course has a true causal effect. Okay, so we are done with this question and we are done with this chapter. So we will meet soon again for the next chapter exercises. Thank you. Thanks for watching. If you found this helpful, don't forget to like the video and subscribe to the channel for more content like this. See you in the next one.